Welcome back. Here we are with our Python course. Today we're going to talk about files and text mining. So first, a little session about how to even work with files in Google Colab. The problem is, if you think about it, that Google Colab is actually executed, the programs you write are executed on Google servers. They don't run on your computer. What you have on your computer is only a local browser, and in this browser you see a web page in which you write your code and your text, but this web page itself is in reality hosted on Google servers. And so whatever text you enter there and whatever code you enter there is in reality transmitted to Google servers and is sitting there. So whenever I try to run a program in my browser, what happens in reality is that my browser connects to the Google Colab server, which is somewhere at Google, and the program runs there, and the output of the program is redirected again to my browser so that I can see it. This is why the first time you run a program, you have this delay, because you have to wait for Google to give you a server, to find one that's free, or to start a new one, and then to connect you to that, and to start your program, to load Python and so on. And all this takes time. And after this first time, you have the connection. Google leaves your server running for a while, and the subsequent invocations of your program are much faster because now your program is already running there. But this you need to understand in order to understand what's happening with files. You cannot just, in a Google Colab program, open a local file, because local for you is your computer, but local for Google Colab is, Google server. And since this server is started anew every time you execute a program, right? Open a notebook, it doesn't have any files. Your files are not there. It's an empty server. So when you try to open a file that you know from your computer and you try to open it in Google Colab, it will not be there, right? Because Google Colab is somewhere else entirely and has no files by default. So one way to make it work with files is to upload the files you need the moment you need them. So that's just one additional step if you are not working with all your files. If you're just working with one or two files, then you can upload these files to Google Colab the moment you need them. Then they will be passed through your browser to Google servers, stored on Google servers. You get a name back under which you can open this file, and then you can open this file that you uploaded. And for most cases, this is okay because Google Colab is mostly used to do, statistics, data processing, things that require one or two or a small number of files that you can upload individually. Of course, this wouldn't work if you try to write a program that searches all your files for a string, let's say something like that. Would not be possible because then you would have to upload all your computer to Google Colab, which you cannot do, right? Okay, so in our case, this is good enough. We upload the file the moment we need it. Another way to do files is you can open files on your Google Drive, because that's also Google, so the integration is there. You can, from your Google Colab program, open a file that's on your Google Drive. So this is possible, and then also in this way you could exchange data. But we don't do this here. We don't want to go into Google Drive, because that's a different thing and it distracts us, from what we're doing with Python. And some of you perhaps don't know whether you have a Google Drive and where it is, and perhaps you've never used it. And so this only complicates things. So we want now to just go the easy way and say we upload the file as we need it. So let me have a little sip of my morning coffee. And now we are going to see how this works. And so the way this works in Python when it runs in Google Colab is you use files.upload, which is a function that will upload your files to your Google Colab instance. Obviously, this whole thing would work much differently if you were using your local computer. If you don't program in Google Colab, but you program, on your computer, writing perhaps your Python script in an editor and then executing it locally, then you don't need to upload anything. There is nowhere to upload. Then you would directly open the file on your hard drive. But since this whole course is based on collab, we now go the collab route. So you have this files upload function, and the moment you call this, it will display a choose files button where you can choose a file, you can click on it, select a file, and press OK, and then it will be uploaded. And what you get back from files upload is a dictionary. And this dictionary contains as its first element the name of the file that was uploaded. And then you can use this name to open the file. So this is good because your program normally doesn't even know what file name was uploaded, right? Because you don't program it. The user selects it at the moment the program is running, and the user can select whatever they want. And this whole file selection dialog is not part of your program, right? This is something that the files upload mechanism does for you. So you wouldn't even know what the user has uploaded and how the file is called. This is why you use the return value from files upload to open the file. Okay, so we upload a simple text file, save it somewhere, and then read it back. And here's the code to do it. So you see how this works. So the first thing that happens, we import the necessary library or module, as they are called in Python, from google.colab import files. So this is what you use to access file functions. And then we run the upload function. So we print, please upload your text file or something, to guide the user. You have to alert them to the fact that now he has to select something. You cannot just press upload and then a button appears, select a file without telling your user what file is expected and what they are supposed to do. So make sure you clarify in the dialog with your user what they're supposed to do next. And then we call files upload, and this returns a dictionary, as I said, and here is the dictionary. We call it uploaded. So the file name is the list of uploaded keys 0. It's a dictionary. We transform it into a list, and from this list we get the 0th element, means the first element, which is the file name. So just, ignore this whole thing. This is how you get the file name. Just learn it, copy it. Ask Google for this line. There's no need to understand, exactly what uploaded contains and what the keys are if you just want to occasionally upload a file. Okay, and then just to make sure we have the right file name, we print successfully uploaded file and the file name that we get from this uploaded dictionary. And now we can open and read the file. It says in a safe way. I will explain in a moment what this means. You print file content or something, and then you have this incantation here, which is always the same when you deal with files, with open brackets file name, comma R as file handle. Now this needs a little bit of unpacking to understand what's happening. When you open a file and you want to work with it, whether it's locally or on Google, doesn't matter. In any case, the moment you open a file, your operating system has to know about it, because the operating system is responsible for giving you this file, making it available, right? And in an environment like Windows, different programs run at the same time. So somebody could, for example, take your file away while you are reading it. Let's say the file is on a USB drive, right? You have it plugged in, you open the file, start reading it, the user takes out the USB drive. Then your file is lost while you are reading it. This should not happen. It's even worse when you write data to a file and somebody takes the USB drive out. Then you have lost your written data, and perhaps this is your last copy of the written data. Let's say this is some kind of measurement that you are doing, or you're filming something, an event, a solar eclipse, and then, the whole film is gone and you don't have this film. So this would be bad, right? And this is why operating systems go into some trouble to make sure that the applications know which file is there and the file is there when you need it. And this is why there's all this opening and closing files mechanism. So opening a file doesn't do anything except telling the operating system, I now want to work with this file. And I also tell it how I want to work with it. Do I want to just read it or do I want to write it? Because again, this is different. One important difference is that if you open a file for reading, multiple programs can read at the same time. There is no problem with having 10 programs reading the same file, as long as they are reading it only and not changing it. And this is something Windows then will allow, right? Your operating system will allow multiple programs to open a file for reading. But when a program opens a file for writing, then normally you want this program to be the only that opens this file for writing. Because having two programs change the file at the same time would be catastrophic, right? Because one program doesn't know what the other is doing. It thinks it's writing, in the third line, but by then the third line has become the 15th because the other program inserted some lines before. So this would not work. And this is why, again, normally there are some exceptions to that, but normally when you open a file for writing, only one program can write. And when a second program tries to open for writing, a number of things can happen. The operating system can say, no, you cannot open it for writing, or it can block the program until the file becomes available for writing, until the other program closes it. And this is now why you also need to close files, because if you open a file for writing, nobody else can write to this file, and nobody else can, take out the USB drive, for example, without getting an error message, because you keep this file open for writing. So this is why it's very important when your program opens a file that it also closes it. And closing it means, again, just telling the operating system, I'm done with it. I don't need this file anymore. You can do with it whatever else you want or whatever other programs want. And so I have to open a file and I have to close it, because if I don't close it, I'm blocking the whole computer. I'm blocking the user from operating on this drive, from taking it out, putting it in his pocket, or other programs writing the file. So you have to be very careful in opening and closing them. And this is what safe means. Opening safely means I open the file in a way that it's closed automatically when I don't need it anymore. Because people tend to forget to close it, right? You write your program, you're interested in the data, who cares whether I close the file? And so this was a problem in the past, right, in other languages. And this is why Python has this with construct. And the with is nice because it uses a Python block. And blocks are, very common in Python, with conditional statements, with loops. We have all these blocks. And with, it's a similar block. With opens a block, and within this block, the file is open in the way that you requested. And after this block is over and you are out of the block again, the file closes automatically and the operating system is notified by Python, without you doing anything, that you are finished with this file. And this is why it's called a way of safely opening a file, because you can open it and forget about it. And when you are done with reading it, it will be closed automatically. And this is what the file handle now is also. A handle, is something by which you can hold something like my coffee cup. And the file gets attached a file handle, again, by the operating system the moment you open it. And you can only access it through this handle. And so this gives the operating system some control over who has the file, because the operating system only gives you the handle as long as the file is open for you. And when you close it, your handle becomes invalid. Your handle is not connected to anything anymore. So you cannot accidentally write on a file or even intentionally, right, after it has been closed. Because after it has been closed, your program does not have a valid file handle anymore. So you cannot access it. You would be trying to write to an invalid file handle that is connected to nothing, and the operating system will give you an error and be unable to write anywhere. So your file handle is a way of making sure that you have the right to do something with the file, because you have opened it in the way that you are saying. And a file handle that's open for reading can only read. A file handle that's open for writing can write. A file handle that's open for both, can do both, can append to the file, for example. And so this is what we are doing there. With open, the file name, R says how I want to access the file. Do I want to read? Do I want to write? do I want to append? And there are different letters you can give there. I will put them on the screen as file handle. And the file handle is the handle that you will get back from this with call. So at this moment, the file handle, you don't have it. It's a variable that you have never used before. You have not initialized it. This variable is given to you by the operating system, right? If you see at the program here, we never declare the file handle. This is given back to you by your operating system if and when the open is successful. Of course, the open can fail. If somebody else already writes the file and you try to open it for writing, you will get an error message. The open will not work and the with will not enter the with block. So then you can catch this error, you can give an error message or something. If we enter this while block, then we know we have a file handle, the file has been opened successfully in the way that we said, and now we can do the operation that we announced when we opened the file. And so we opened this here for reading in this example, and now for line in file handle. Now the file handle behaves as if it itself was a text file, right? So it has lines. This is a little weird, right? Because it's a file handle, it's not supposed to contain the content, but this is how it works. So you have the content there under this file handle. And so I can really iterate over the file handle because it's a text file and get the individual lines out. So for line in file handle, and now I could do something, print the line. In this case, I print line dot strip, and the function strip, the method strip of the string object removes white space at the beginning and at the end of the line. So if the line has been indented by putting some spaces in front like we do with Python blocks, then strip would remove those. This is just a cosmetic thing. When you print the lines from a file, you don't want to print all this white space and make a mess on the screen. So we just strip it so we see the content without the white space at the beginning and end. Okay, and that's it. And now I can show you what this looks like when we execute it. So here I click on it, and this takes a moment, as always, to start. Now I can browse for a file, click, and I can take my new text document here. I uploaded it, and now it prints the file content. So it uploads the file, new text document text, and then it gives me the contents of the file line by line. And this is what I saved in this file, right? This is exactly what's in that file. Yeah, and so this is how you deal with files. And now you could do within this with block, you could do whatever you want. It's good practice to not do too much in the with block, but to just read the file into a variable and then leave the with block and continue outside. Why? Because you don't keep the file open, right? You should read your files, let the system close the file, go out of the with block, and continue to process your file, because your processing can take longer, right? The program can run for an hour, for 2 hours. You don't want to have the user stuck there, unable to take out his USB stick because you are still processing, right? You want to open the file only as much as you really need it, open it, read the contents, close it. The user can take out their stick, go their merry way, and you are now free of the connection to the file. The file can be written, it can be opened by other programs, and your program continues with the variable. So normally you would really, your with would just be one line or two, open the file, read it into a variable, leave the with block, the file will close. The user is free to do what they want with it, and you continue the processing with your variable. So in this case, we did not read it and then print it. We printed it directly because this just takes less than a second, right? So it's not a problem. But this is how you would do it. This is a good practice, right? Not leaving the file open and working for hours within the with block, because then you're blocking the user from doing something else with the file. Okay, the next thing we will do in the next session is to count word frequencies within the file. So come back to the next video to see how this works out. Thank you, and see you there. Bye-bye.